Now we're going to talk about how we find it in a table. And the first part is actually really very clear and very simple, I think. So if I was making a table, let's say I have a table, I want it to be that. I want it to be 1, 2, 3, 4, 5, 6, 7. And then I'm going to make little boxes in my table. And we'll do this. Okay, and I'm going to double that table up really quick. So we'll copy it, and then I'll paste it down here, just like that. Okay, so I'm going to use the same two rules. So my first rule is y equals x plus 3, and my second rule is y equals I'm gonna leave it like I kind of like showing that you can put the y on either side and it's still going to fit. So my first one, for my first equation, it is I have an x and a y, and when x is 0, again, I'm really just referring to all of these same pairs of numbers here. But when x is 0, y is going to be 3. When x is 1, 1 plus 3 is 4. When x is 2, 2 plus 3 would make y 5. When x is 3, 3 plus 3 would make y 6. When x is 4, it would make y 7, and when x is 5, it would make y 8. If you're looking at, let's see, I actually need to change this ink a little bit. So for my other pattern, right, when x was 0, y was negative 1. 2 times 1 is 2, minus 1 is 1. So when x is 1, y is 1. When x is 2, 2 times 2 is 4, minus 1 is 3. When x is 3, 2 times 3 is 6, minus 1 is 5. 2 times 4 is 8, minus 1 is 7, and 2 times 5 is 10, minus 1 is 9. So that's how we would get these tables. And when I draw a table like this, the solution will be the common set of number pairs in the table. The solution will be the common set of number pairs in the table. So in this case, right, it's going to be the 4 and the 7, right? That's obviously the one spot. Like 1, we've already talked about it being our answer, right? These match. But also, if we just look more carefully, we'll notice that when x is 0, it does not match the other pattern when x is 0. So when x is 1, it doesn't match the other pattern when x is 1. When x is 2, it doesn't match the other pattern when x is 2, right? Because when x is, the reason why these don't match is this is 2 and 5. When x is 2, y is 5. And down here, when x is 2, y is 3. That's not the same thing. When x is 3, it's 6. And then down here, when x is 3, it's 5. And over here, when x is 5, it's 8. And when x is 5, it's 9. The only place where they're the same is in both cases, when x is 4, it's 7. So we have matches right here. And then the rest of these don't match. Actually, I think I like this arrow better. Those don't match. These don't match. These do not match. These do not match. These do not match. We have the one green match. So that's really easy to see. However, so tables I find pretty simple, but there are times when you might be looking for a table where you might be looking at a table and the match is like it's been skipped over for whatever reason. So what if I cannot see on a table where the match is? What if I cannot see a number pair that matches? So 1, 2, 3, 4, 5, 6, 7. I'm going to make the same tables again, but we're going to show slightly different data on the tables so that we can talk about this. So in this one, we will show, let's say that we have on the top one, it's for the same pattern. We're still doing x plus 3 equals y, and we're still doing 2x minus 1 equals y. So we still are doing both of these rules. And so for the first one, we have x and y, and when x is -1, y is 2. When x is 0, y is 3. When x is 1, y is 4. When x is 3, y is 6. When x is 5, y is 8. And when x is 7, y is 10. And then when I do the other one, I'm going to put in this the same data set for the data for the same values of y. So 0 or -1, 0, 1, 3, 5, and 7. So when x is -1, y would be -1 times 2 is -2, minus 1 is -3. When x is 0, we've already done that one. 0, this would be -1, and we've already done 1 as well. We've already done 3. 3 times 2 is 6, minus 1 is 5. 3 times 5 is 10, minus 1 is 9, and 2 times 7 minus 1 is 13. So here we have these two data sets, and in this case, like, none of these are the same. Nothing matches, right? In these two data sets, I cannot see any points where, like in purple -1 of figure -1 does not match blue figure -1. Figure 0 does not match figure 0. Figure 1 does not match figure 1. Figure 3 does not match figure 3. Figure 5 does not match figure 5, and figure 7 does not match figure 7. So in order to figure this one out, I'm actually gonna copy this. Copy, and I'm gonna bring it way down here. I'm gonna paste it again, just so I don't have to redraw that in a minute. And I'm gonna try to erase these red circles on this one, so we can talk about these ones in a minute. Okay, so on this one, nothing matches. So sometimes you won't see any pairs that match. I'm going to write that in so that people reading this later can see it. Sometimes you don't see any pairs that match. don't see any matching number pairs. So what do we do here? We talked about this in class a little bit, but you need to think about what you know. So think about what you know about like how equation or how the point of intersection works. So when I draw a, if I was to draw a graph here, oops, let's make it straighter. If I was to draw a graph here, I know that my, I know that my first spot, I want to think like without actually looking at this, without actually looking at a graph, I want you to be able to figure this out. And so one thing I know about a graph is that when I see a point of intersection for any point, this is actually, let's see, these are actually going to be for different graphs that we have not seen before. You know what? We'll just make it the same. We're going to make it the same graph. So this one is going to go like that. And this one is going to go like this. So when I draw this graph, right, what I know is that when you see the point of intersection, right, I know that purple is higher before the point of intersection. Purple is higher. Draw this line one more time. So we'll do purple is higher. On this side. And then right here, oops, don't know what I did to do that. Right here, at the point of intersection, they're both the same height. They're both the same. And then after the point of intersection, blue is higher. So what we need to do is we need to think about what we know, right? I know that when I'm looking at one of these graphs, the lead is going to switch at some point, okay? And so when I look at these two tables, I could look at who's in the lead, okay? And when I look at both of these tables down here, I can see that, let's see, at first, in figure number -1, purple is higher. And in figure number 0, right, purple is 3 and 0 is at -1, so purple is higher. And in figure 1, purple's at 4 and 1 is at Y. In figure 3, purple's at 6 and Y is at 5, so purple is still higher. In figure 5, purple is 8 and blue is now 9. So blue has just become higher. And so what that tells me is that looks like that somewhere between 3 and 5 is where my lead flips, right? So I know that my lead flip, even though none of these points are the point of intersection, I know that the point of intersection has to be like in this area. It's got to be somewhere in here. So